Hello. Hello. Yeah, I know that wasn't that much time to introduce yourself. I'm sorry. But we're going to get started on time. I'm German after all. I gotta keep time. Very important in our course too. Hello, welcome to the Code Chrysalis Demo Day. Yes. So what I will not be doing is I will not be introducing Code Chrysalis, because this day is all about our lovely students and what they achieved in the 12 weeks. But what I do want to do is give some shout outs to some of our partners who continuously work with us to keep the course going and provide very unique experiences. So I want to give a special thank you to Pivotal Labs, who are doing the unique opportunity of having a 2-day product development workshop, product development and discovery, which is very unique, and all of our students enjoy it so far, so thank you for that. Big thank you to Rakuten RapidAPI. Every cohort we do a collaboration with them and have students create applications with their platform, and they get to present those applications at Rakuten RapidAPI to some people pretty high up. So hey, yeah, thank you for that. And also a big thank you to RGA, who also provide a day-long workshop for our students. Again, going a bit through product development and how they do things, and also like design, which is very important for software engineers. It's not just about clean code, unfortunately. It also has to look good, otherwise no one will use it. So thank you, RGA. And with that, I'm going to give it to our MC, the Master of Ceremonies for tonight, Omar.
So my name is Omar, and I'm your Master of Ceremony for the evening. Thank you very much for coming to share this moment with us. These 12 weeks have been an adventure, some down, many ups, but one thing's for sure, the learning curve has been phenomenal. Before we kick off, I'd just like to note that we have one guest here tonight that we're very lucky to have with us, Ide-san, and I'd love it if you can say a few words before we get started. Ide-san is the former chairman of Sony.
Hello, nice to meet you. I don't know how many people understand Japanese. I speak in English though. Code Chrysalis. How many Japanese understand the meaning of chrysalis? Yeah, I can for somebody. You are Japanese or? Yes. Chrysalis, what does it mean? Yeah, very good. Do you know Sanagi? You are still Sanagi. Sanagi means before it can butterfly. It's called chrysalis. Sanagi. That means chrysalis. That means today I understand the graduate of 11 people. They are all still Sanagi. So I think the future is really, huge in the future. So code is one thing, but there are so many things to be done. So congratulations for the graduation of today, but there are so many bright future ahead, I believe. But in Japan, the education is very much behind. So the code is very important. So when I get to know Kakani-san, my former secretary at Sony, working for Sony Interactive Entertainment in Silicon Valley, and she telephoned me that my important friend going to Japan to make a kind of Code Chrysalis. So I didn't understand anything, but we are really falling in love with him. So that was first sight. So I really fantastic. 2 years ago, it's incredible to think about such kind of meeting. So congratulations everybody, and I really appreciate for the supporting company of Japan and also good students. I don't know how many dropouts the goes, but anyway, congratulations. That's my short speech. Thank you.
Thank you very much. So first off, I would like to invite Team Omikuji to the stage. Their app Omikuji. So their app Omikuji is named after the traditional Japanese fortune slip, and as Felix was mentioning, it was developed using Rakuten RapidAPI. For those of you who don't know, this is an API marketplace through which you can discover and interact with a range of APIs all in one place. So they came to present the marketplace to us. We built the app and presented it to them 3 days later. But without further ado, Team Omikuji.
Thank you very much, Omar, and thank you all for coming out today. We are here to present to you an app idea that we have created. It's a mood stabilizer. So first off, to start off, to introduce ourselves, my name is Yuma. I'm a filmmaker by way of Los Angeles. I'm here because I'm interested in VR and AR, and I have my own production company.
I'm Keisuke. I'm a software engineer. I previously worked at ICT companies before.
My name is Chaz. I'm from Northern California, and I'm at Code Chrysalis to make the transition to becoming a professional software engineer.
Hello, my name is Yuma. I was working as a professional ballet dancer in the Republic of Georgia, now trying to support athletes and artists using technology.
So with a group of diverse people, we decided to start off by creating this app. So to walk you through it, we're going to share what that app idea is, as well as to demonstrate it, give you an idea of our system architecture, as well as the technologies that we ended up using. We're going to share with you some challenges and then the conclusion that we were faced with.
Our app idea, first we're going to take a picture of our user, and then we're going to judge their emotional state. And then we're going to stabilize their mood by using GIFs and text. And by stabilize, I mean if the user is sad or unhappy or has a negative emotion, we're going to show them images and text to make them happier. However, if they're happy, then we're going to show images and text to make them a little sadder. All right? The name and design is inspired by a traditional Japanese Omikuji. It's a fortune-telling slip.
So let's dive into demo. All you need to do in this application is to upload a picture with your face. So let me upload this picture. And you can now see loading spinners is working. It's going to take a while depending on the connection, and you will see the result, yes. So when you look angry and fearful, it's going to give you compliments. I love you more than a poet loves their poetry. Nice. However, when you upload some other picture, like showing positive emotion, it's going to say, I could slap you so hard, the skin from your face will snap back and hit you again. Let me also try some other edge cases. When your face doesn't really show emotion, it's gonna give you that you're already neutralized, so no one can see your inner feelings. What about your face doesn't look like human? Then it's gonna ask you that if you're human or not. So this is our application.
So system architecture. We deploy our application to Heroku, and we use the JavaScript Vue.js as frontend. We use Node.js as backend. The basic flow is user upload the picture to our server. Our server calls the Microsoft APIs and get user emotions, and also call the two APIs through the Rakuten APIs and get the result and return it to users. Now, what kind of technology we used? We used the Heroku as deployment environment. We use Vue and Beautify as front-end framework. We use Express as server-side framework. We use Node.js as runtime.
Some basic challenges that we ran into initially was trying to figure out how to present each person with their own individualized slip. So we wanted a random GIF for each individual person based on their emotion. We also wanted to support edge cases. What if the person was taking a picture of a dog or a Pokemon, for example? We wanted to be able to provide feedback in those situations. Another thing that we worked very hard on was being able to provide a proper chart, something that fit within the design of Omikuji and the brand, as well as being able to give people feedback on exactly what part of their emotion the picture was registering as.
In conclusion, we found working with Rakuten Rapid APIs to be very convenient. There was one API key for multiple APIs, and they had a nice web-based interface where we could test the API on their website, which we also appreciated. All right, so thank you for seeing our presentation. If you're feeling brave and you want your mood stabilized, please check in this QR code here, and you can get your mood stabilized. If you're using your cell phone, please hold it sideways for the optimal viewing experience. Thank you.
Thank you very much, Team Omikuji. I have to say I was feeling very happy at the beginning of demo day, and now my mood is kind of neutral and mellow after that slap. Next up, we have Toshy, who will present a game character database built with Kotlin. Now, the context for this application is something called Polyglottal Week. At Code Chrysalis, one of the key principles is that engineers should be autonomous and versatile. So Polyglottal Week was our opportunity to get our hands dirty with languages that we hadn't experienced before. So we had a range of projects in Python, Golang, C#, Ruby, and so on. So without further ado, Toshy.
Thank you, Omar. Thank you for coming today. I will talk about Kotlin. First, introduce myself. I work at NTT Data now in charge of maintaining and developing our company's in-house framework based on Spring Framework. Recently, I interested in front-end technology, for example, Vue.js, VR, something. Yeah. Recently, I joined VR events. I'm interested in more and more. Why I chose Kotlin? I wanted to use Kotlin with Spring Framework from before because I heard Spring Framework, Spring Boot support Kotlin, so I wanted to use from before, and I have some Java application. If I create Kotlin application, Kotlin coexists with Java application, and I wanted to understand the difference between JavaScript and Kotlin. Why JavaScript? We students have to use JavaScript making full-stack applications, so I wanted to understand about JavaScript and Kotlin. So I made application. This application is very simple application, but covering CRUD and full-stack application. This application made for keep a track of characters, scores. Now, I will explain about applications. This is login page. I don't want to watch my record, so I create authentication. This is application. This is a character and name and score of, for example, technique of tennis, stroke and service and stamina and speed and total. So already I created some characters. So I will create new characters. First, upload pictures. character. Upload. After that, I input scores and create created if mistake or update something. For example, change values to 100. Change it here. If you don't need this character created, disappeared. Yeah, this is a very simple but covering CRUD system logout. Return to the presentation. Yeah, this application made from many technologies, not only Kotlin, but also Cloudinary, other storing pictures, Spring products as application framework, Spring security as authentication, and TypeLift as a template engine, and Bootstrap as a CSS framework, Maven as a build tool, and PostgreSQL as a DBMS. Now, return to about Kotlin. Kotlin developed by JetBrains before. This is open source and statically typed language and functional programming. And Kotlin, we can make JavaScript from Kotlin source code. And new safety, it is important features. I will talk about difference with JavaScript. Yeah, this is a Hello World application in Kotlin. Difference from JavaScript. In JavaScript, defining the function is function, but in Kotlin is fun. And defining types and variables in Kotlin is variable and types reversed. And it is the same features as JavaScript, distinguished, read-only and relatable. In JavaScript, as const and let, it is same features. It is important, I think, is new safety. It is safety for now. If users makes like normal this, you can use now, but if you allow to hold no, added question mark after types, it is okay. You think now. This is a Kotlin features. Thank you for listening my presentations.
Thank you very much, Toshy. Next up, we have myself, so I will leave you in the good hands of a better-looking master of ceremony, Ian. And Ian equals MC squared, as we like to say.
One of the things that we have to do in our time here is be able to deliver a 45-minute tech talk. What that means is that during the time that we're here, we have to research in the back end, in between all the crazy things that we're expected to do, we also need to be able to present an idea. For many of us, this may be the first time we've ever given a 45-minute tech talk, but in this particular segment, we are actually condensing that down into 5 minutes. So it's very tight.
Thank you very much, Ian. So today I'm going to talk to you about blockchain for international trade and getting started with Ethereum dApp development. As Ian said, this is a condensed version of a 45-minute tech talk, so I will be giving you a very high-level overview. But first, a little bit about me. I come by way of Switzerland, and I used to work for a company that trades agricultural goods around the globe, like coffee, sugar, rice, wheat, and corn. But ultimately, I was more interested in the technologies that could transform this business, foremost among which is blockchain. So I decided to enroll in a coding bootcamp and found my way to a new country in the process. So one thing about international trade, you quickly realize that the day-to-day is very much about managing risk. And some of these risks stem from trust frictions. So you can ask, for example, if you buy something, will the seller deliver? And if you sell something, will the buyer pay? Today, these frictions are managed with a complex ecosystem of intermediaries and many layers of paperwork. So for example, a bank will act as a trusted middleman to process a payment. A shipping company will issue a document to establish the ownership of the goods. An inspection company will issue a document to certify the quality of a shipment. And this paperwork cannot be digitized because you reliably need to know who issued it. And if this document is a title of ownership, you need the original. You can't have duplicates. So where does blockchain come in? Blockchain is a technology of trust, and arguably it's the first technology that allows you to own assets securely in the digital realm. So in the international trade sense, you can think of exchanging title to a shipment digitally, without the paperwork. Same thing with the inspections and certifications that come with shipments. You can track them, again, in the digital realm. You can record contractual arrangements and execute them algorithmically if the terms of the contract are met. Now you can validly ask, why blockchain? Theoretically, Amazon can come in and build a mega app, and likely it would be good. But the thing about blockchain is that it's neutral. It's not controlled by one company, one bank, one shipping line. It's a neutral platform, and that's what makes it appealing to this ecosystem. So I decided to try my hand here at Code Chrysalis at developing my first decentralized application. And I chose Ethereum, not because I think Ethereum is better than the alternatives, but because I think it is one of the easiest to engage with if you want to branch into blockchain as a software engineer. And I started off with this confusing cloud of words that I didn't understand, but first it was helpful to kind of chart what a basic blockchain application looks like. So you start with the Ethereum blockchain, and then you have the language Solidity, which you use to write smart contracts that are then compiled into the Ethereum blockchain. Next, you have Web3.js, which is the official JavaScript Ethereum API. It's the way your apps can communicate with the Ethereum blockchain. And finally, on your client, you have an Ethereum client called MetaMask, which allows you to sign Ethereum transactions. Next, you quickly realize that there's an interesting tool called the Truffle Suite, and you can think of it as an Ethereum Swiss Army knife. It comes with a set of tools, first among which is Ganache, which is a development blockchain that you can install on your machine and makes it quite convenient for development purposes. You have Truffle as well, which has a bunch of functionalities like automated testing for your smart contracts, Solidity code compilation, and a bunch of helpful boilerplates. And finally, Drizzle, which is a front-end library allowing the dApp development to be a smoother process as far as the front end is concerned. So I set out to build an app that implements the basic principle of a blockchain-enabled trade transaction. And that is basically that the seller can only claim payment once the designated third party, be it a shipping line, an inspection company, validates on the blockchain that the seller has fulfilled the contractual obligations. If you're interested, feel free to check out the GitHub repo. And on that note, thank you very much for listening. As I said, this is a condensed version of a 45-minute tech talk, which you can check out the full one here for all of us. And of course, feel free to get in touch using those details. All right, so next up we have Brian Lee. Brian is a creative, he is a musician, and he will take us to the intersection of music and artificial intelligence. Now, if anyone here is considering attending Code Chrysalis, delving into the world of artificial intelligence is really a path for true and brave warriors. So it's quite a hard, difficult undertaking. One thing about Brian is that we all thought he slept here at the beginning. You know, the ones who would arrive early, say at 7:30 a.m., we'd already find him here coding away, working hard, or at least pretending to. We confirmed that he does not actually sleep here, but nevertheless, he is a diligent and hardworking software engineer. And without further ado, Brian Lee.
Thank you guys for coming out today. Today I would like to talk about music production with artificial intelligence. Yes, artificial intelligence is about to take jobs from musicians as well, but it's okay because musicians have been fighting unemployment for a very long time. So, a brief introduction of myself. My name is Brian Lee. I'm from Busan, South Korea. I'm a musician, I'm a programmer, I love Kyushu cuisine, and I love ocean. I do apologize if I'm a little bit rushed today. It's probably because of today's objective, which is to make a pop song, which is usually 3 minutes, in 5 minutes. It's not ridiculous, it's Code Chrysalis. So what is a pop song? We're not going to go into music theory, but the basic idea is you are building up music blocks to intensify emotional experience, and then you're deconstructing them to give audiences smooth landing to your outro. Today we are going to try to make 2 blocks of music. One is this first part, and the second is the hook or chorus part. So stop talking about music and let's actually make music. So before we dive in any further, I would like to introduce the application, artificial intelligence application we're going to use today. It's called Magenta. It is a deep neural network application that is trained on big sets of musical library. And the functionality we're going to use today is continue. And what continue does is it takes a sample music and it generates music that will come after it. So let's talk about what kind of sample data we should use in order to use this machine efficiently. So basically the idea that we are trying to do here is we're trying to abstract the idea of harmony. And through my trial and error, the most important thing is we need to clarify the repetition, simple repetition over multiple instruments. So the best data set I found is game music because they have many instruments, but very simple repeating loops. So while we're listening to it, I would like to explain what I would usually do. So basically, I will start off by labeling each part. This will be main chord. And then I will find parts that I will not use. So this is a second bass line, and I don't think I'm going to use it because main bass line is here. So I'll delete that. And then next thing I'm going to do is I'm going to tell the application that our music starts, where our music starts and where our music ends. So as you can see, you have a nice clean break at the bar 13. So we're just going to use that first small half so that the application doesn't get confused over too much data. And with that setting, we're going to go to a step where we have the artificial intelligence's output. So in this second stage, what we want to do is we want to listen to the output that the machine has given us and try to tell if we like it or not, try to process it, delete some of the notes that we are not going to use. So let's just try processing only the main chord part, which is this yellow, blue, and purple. The one that I'm going to use is the 5th variation. can notice that it makes a pretty good music, which is surprising because a lot of artificial intelligence makes very computery music. But with this track, I do like it, but I think it jumps into the exciting part a little bit too late. So I'm going to delete the first. I'm going to delete the first 2 bars, and I'll make it jump into it a little bit earlier. Okay, let's listen to it. Okay, after the second listen, I can say that this note right here in this spot, I don't like it, so I'm going to delete it. And also, as a music in general, I feel like it's a nice loop, but it can go a little bit higher. It can take us to a bit of a more emotional intensity. So I'm going to try to add some notes. I feel like... Let's listen to it. I think I like it. I'm just going to use that. And, so next step we will jump into is basically what is called mixing. So you would have these blocks all processed out, and you will simply just use different instruments to make music genre of your choice. So like here I have set it up. This will be our intro to our music. This will be our verse 1. This will be our hook. And then this will be our verse 2, and then goes to hook, and then we will use intro for our outro. So we lay them out like this. So with that, I would like to bring you to the conclusion of today's talk. I want you to think about how artificial intelligence is going to, assist us in the creative process in the future, because using this application, it was a very exciting experience for me. It showed me a new workflow of making music, and I think this empowers musicians and also people who are just generally interested in music to make music without much stress. So that is my talk. If you are interested in AI and music, please come talk to me. Thank you for listening.
Thank you very much, Brian. Next up, we have Carlos Castro, and we're going to leave technology for a little bit and talk about fashion. So who here has heard of Docker's shoes or Docker's pants? Yes, okay. So you can wear them on a sailboat, you can wear them in the office.
Omar, we are talking about Docker technology. It's not about...
Oh, Docker technology. Oh, right, okay. Sorry, start again. Docker technology. That is a powerful technology for software engineers. Carlos will take you through it.
Thank you very much, Omar, for that lovely introduction. Today I'm going to talk to you about Docker containers. First, a little bit about myself. My name is Carlos, and I have more than 3 years of experience working in a software consultancy in Mexico City. I have worked with applications built in Java, technologies such as JavaScript and ActionScript. So, let's see what's up for today. I'm going to talk to you about what is Docker, what Docker containers are, Docker images, and a little demo. Okay, so first off, what is Docker? Docker is an open source platform for developing, shipping, and running applications. So it allows you to ship your application without caring about too much who is receiving it and the infrastructure they have to run it. So it allows you to have shipping and deployment very easily. It also runs everywhere, so if you had servers running on Windows or on Linux, it allows you to run on those platforms. So what is a Docker container? A Docker container is a standardized unit of deployment. It is disposable and it is lightweight. It is an isolated environment for your application to run with all of its dependencies. So it has all the right amount of data that your application needs to run. And what would you choose Docker containers as opposed to as a virtual machine? Yes, you can solve some problems using virtual machines, but you can see this as this sort of a spectrum where the most generic way for you to ship an application is using a virtual machine. But you are shipping an entire machine, which is gigabytes of data. And the other side of the spectrum, it is the less generic way to ship your application when, for example, in the Java environment, it will be a jar file. But you will have to be aware of or carry about whether the person or the people who are receiving your application, how they're going to run it, and if they have the infrastructure to do so. So what is a Docker image? For those of you who are fans of Rick and Morty, we can see Docker images as a ME6 box. And the ME6 box works creating ME6 containers. And the same way Docker images create Docker containers. They are the basis of all containers. So how does that work? The ME6 box creates a Mr. ME6, and then the Mr. ME6 is assigned a task. And when it completes the task, it will disappear. In the same way, Mr. ME6, a Docker image will create a Docker container, and then when the Docker container finishes its task, it will disappear. In the same way, a Mr. ME6 box can create multiple Mr. ME6, in the same way that a Docker image can create multiple Docker containers. So I created an application that is built for interact with Docker images and Docker containers in a non-CLI way that can run in your browser. So if you scan the QR code, you can find the GitHub repo. So let me show you. This is the overview of the Docker management dashboard. You can see all your Docker images at a glance, and you can start Docker images. So I'm going to start one. I'm going to have prepared here. It already started, and it's running on port 9000. So if I go to run my application on port 9000, it is not working. So why does it's not working? Because, as I said, the Docker containers are isolated by default. So my Docker container is running, so my application is running, but it's isolated. My computer does not know that it has to go to my Docker container and serve that application. So I have to bind the ports. And that way I can do it. I can bind the ports to anywhere, any port I want in my local host. In this case, I'm going to do it to a 7000 port. So if I start my container, it is running on port 9000, but this is port 9000 inside the Docker container. So if I go to my 9000, still not working. But if I go to my 7000, you can see this beautiful application created on Vue here at Code Chrysalis in just 3 days, because Code Chrysalis. So how does this work? In the front end, we have Vue and Beautify. In the back end, I'm using Node.js and Socket.io to get the logs, and everything is interacting with a Docker daemon. And the Docker daemon is handling all the heavy lifting, interaction with the Docker images and the Docker containers. So summarizing, Docker technology helps you with shipping and deployment more fast. It allows you to ship the right amount of data that you need in order for your application to run without caring too much about who is receiving it and how they are running it. That allows you to scale more easily. That's why it's so popular with microservices. And it allows you to have local development environments that are exactly like a live server. So if you have an application running in your production server, you can run it in your local development environment without caring about too much if those environments are the same. Thank you very much for listening to my tech talk. And there is a 45-minute version of this. You can find it by scanning the QR code, and you can find it in this information content. Thank you.
Thank you very much, Carlos. Next up, we have Team Cian, which I am part of. So I will pass you back to Ian equals MC squared.
Hello everyone again. So one of the other projects that we had to complete in our last 4 weeks here at Code Chrysalis was our demo day project. And many people will end up being given this minimum of 2 challenges that we have to solve. I would like to say, maybe even set a high score for future Code Chrysalis cohorts. We accomplished not 2, maybe not 3, but closer to 4, 5, and 6 different challenges. Which seems a little ridiculous in retrospect. You're about to see an incredible use of hardware and IoT developed in just 4 weeks in 2 different teams. So this is Sojournal. I'm very glad to be on stage with them, and I will hand the mic over to Chaz.
Hi, I'm not Chaz, but yeah, I would like to introduce you guys to the application that we made called Sojournal. Sojourn means it's a poetic way of saying trips, and what we're proposing to do today is suggest a way for you to document your trips and your memories. So our outline for today is the inception of our idea, the development flow, and then we'll show you the product that we have developed so far, and then we'll explain you the technology and architecture involved, and what it does now, and the future features. So the problem that we're trying to address is you don't have to be a professional photographer to have thousands of photos on your devices nowadays, and we wanted people to have the context and the story and the memories of the photograph more stored together with the photos instead of photos just being an image. So the idea in solving this problem is, hey, what if we had a specialized camera that captures moments and context for you? And what if we had an interactive application that enables and sparks you to write text and keep memories together with the photographs? And with that idea, meet Frank. Frank loves traveling, and he takes a lot of photos, and he comes back home and shares it with his grandchildren. And he wishes that there is an application that lets him store those memories before telling them to his grandchildren. Meet Susan. Susan is an environment lover. Her trips wouldn't be leisure. She goes on many trips to help preserve environments, and most of the time she will be busy doing her work. So she wants something that will constantly document her surroundings and environment for her. And meet Hank. Hank is a mountain lover. He often goes on hiking, and his hikes usually last around 7-8 hours. And he wants a way to document and make a visual representation of his leisure trips. But it is not a secret that there are already a lot of predecessors to our product. There are a lot of travel-related apps, and if you have an iPhone, in default you can map out images that you have in your gallery. So, what is different about this application? So, our application is an interaction designed to spark ideas. So, if you use iPhone and how they map out the photos, at the end of the day, it's just an image. You remember the context of those photos, but there's no way to record them. And also, we value user privacy. This is not, we are not trying to get you to share it on other social network platforms, or this image will be for you and your use only. And also, our hardware is designed for professionals or individuals that require demanding documentation.
Okay. Before we dive into our demonstration, I'd like to point out that there are 3 components to the Sojournal program. There is the Android application, there is the cloud-based server, and these 2 talk directly to each other. And then there is the camera hardware, which talks to the cloud-based server. And the camera talks to the Android phone through the server.
So, what you're seeing here is a mirror of this phone I'm holding and our app. And essentially, here you have a list of trips or ways to classify photos that we created. And the first one I want to show you is the one called Demo Day, where if I scroll to the end, you can see that the machine that my friend Keisuke here is holding has been taking pictures that are communicating to the app. And you also see the location rendering here in Azabu Jugan. For a more visual representation, we can see this picture here, this strip rather, where Brian took some pictures in Korea, and you can see that the map moves every time I select a picture. I can also take a photo. I can write a comment and upload it over. Now, what we want to show you is something that we were able to do with the Sojourn camera, as we call our device.
All right. So every day when I was commuting to and from Code Chrysalis for the last few weeks, I've been carrying around this camera, and I'm kind of holding it here because the clip hurt and I got some strange looks. So we figured since this camera can take photos at regular intervals with an intervalometer, why not make a time lapse? And so that's the video you see here. The camera took images every 2 seconds, and they were being played back at 12 seconds per second.
Right, so to dive into the technology stack, on the front end we used the React Native framework, and we used Redux as our state container. We used Expo as our software development kit. It was quite convenient on different levels. There's easy access to some device capabilities like location and camera. The Expo app allows you to render your app on your phone as you're building it. And there's also a bunch of helpful boilerplates.
Okay, for the back end, we hosted our photos on Amazon S3. Our server was deployed on EC2, and our stack included GraphQL, Connect, Express.js, and PostgreSQL.
Hardware side, we developed this camera, and we used the Raspberry Pi Model 3 B+, and we attached the GPS module to Raspberry Pi. We attached the camera module to Raspberry Pi, and we wrote the script using Python, and we use Redis as data stores. And and this camera can upload the photos and GPS data to our server. And also, we designed the protection case for Raspberry Pi using 3D printers. This is our overview, and this is assembly. And we attach the clip in this device here, so user can attach this device their pocket and their backpack.
So, to dive into the current features, as you saw, now we're able to capture using the camera that's native to the phone, pick a photo from the library. We're able to comment the photo or add a title to it, and then upload it with its GPS coordinates, and then classify the photos by trip and render them on the map for you to refer to at a later stage.
Hardware side, our camera can take photo and record GPS data. And also can upload photos and data to database. And also, this camera can receive the settings such as interval and start time and end time from mobile applications.
Now we would like to talk about some of the challenges that we faced while pursuing our project. In the application side, we'd like to mention React Native. Prior to this project, we had a little bit of experience with React, and sometimes we found ourselves underestimating some complexity of certain task is going to be, such as making our components touchable and animating styles according to the touches was a very complex dynamic that we struggled to understand for a long time. Also challenging into mobile development was a new fun but challenging experience. Setting up the testing environment and getting used to the whole flow of it was a little bit difficult at first. And also deployment at Play Store. So deploying our app or making our app available on Play Store requires time. So we had to time box ourselves, and we had to carefully plan when we're going to freeze our features and just work on debugging. And that was a new but challenging experience.
For the server, one of the challenges was anticipating the needs of the Android app and the hardware before they'd been developed. Another one was coordinating the communication between the Android phone and the hardware. And for some reason, handling timestamp data was complicated. Computer scientists have been doing it for 50 years, but it's still kind of tricky. So GraphQL, for example, can only handle 32-bit integers, but timestamps were bigger, and so they had to be passed as strings, and there were several other bizarre hurdles we had to cross.
Hardware side, we use a GPS module, but it only works outside. It can't catch the satellite in building, so we had to think using the Rust Redis coordinate. So we use Redis to store the Rust coordinate. So second one is offline data capture. It means offline data uploading. Our camera have to connect the internet. So, but most of the time, our camera cannot connect to internet. So we had to think the offline uploading. So we use Redis to data stores. So it means if request fails, to store the failed request to Redis, and when user restart our device, then try uploading again. So one is interparameters. We have to implement these functions. So our device had to know the time and user's input, and had to set timers. This is a hardware challenge.
Right, so on the future features, on the UI you can always make your product better for its users. And in this case we can add more and more ways to classify your photos by time, by location, by tag. We can integrate further with Google Maps. The list is endless, but this is something we would look into.
Okay, video and time-lapse creation weren't features that we had in mind from the outset, so those are things that we'd like to add. Another thing, if you noticed from the video, that image stabilization might be desirable. That could be implemented with both hardware and software. And there's some other hardware improvements as well. Reducing the size and cost of the unit. There's a smaller Raspberry Pi board we could use, for example. Adding other features such as buttons and lights, so you know what state the camera's in. And some levels might be nice, so you can make sure that it's not tipped in a funny way. And a tripod mount, so you can mount it to a tripod. Right, thank you for watching our presentation. We encourage you to go to and download our app from the Google Play Store. You can scan the QR code right there. All right, thank you very much.
Thank you, Team Cian. So next up, I would like to invite Team Mortar and Pestle. So, who here has Facebook? Who here has Instagram? Who here has taken a virtual reality tour through the data that Facebook and Instagram hold on you? Probably no one. And this is what's really fascinating about the project that Team Mortar and Pestle has undertaken. It's probably one of the first projects at the intersection of data privacy and virtual reality. So without further ado, Team Mortar and Pestle.
Thank you all. We created an application called Mindsweeper. First of all of us probably have encountered Facebook at some point in our life. However, many of you might not know the kind of data that's being mined from you every single time you use it. We wanted to be able to create a unique application that could dive into some of the weirder parts that you might be unfamiliar with. So first of all, we're going to share what our idea was, as well as a little bit idea of our product development flow. We're going to give a brief demonstration of the application that we've created, as well as talk about some of the weird things behind Facebook and the data that we found. We're going to dive into the technology, the system architecture, as well as some of the challenges that we face, a website that we created to be able to help educate people on the security of their own private information, and some of the future features that we'd like to implement. First of all, one of the first things that people will end up trying to do is try and figure out how to reinvent the internet. We were so curious about what are different ways that we could interact with the World Wide Web. Well, it is really wide, but how do we show that? When you are going through several pages on a Google search, you might be unclear as to how all of these different things are connected. Wouldn't it be interesting if we could visualize what that looks like? Well, there's so much data in trying to figure out exactly how to present that we decided to go with something a little more personal, something that many of us do in fact have. And that's our Facebook data. Here's mine, right here. Every single thing that I could download is right here. I have ads. These are advertisers that have my personal information, JSON files that are filled with every single picture that I ever took, including the ones that I should never share publicly. As well as friends that I have, pokes, people that I haven't friended back, personal information that includes my whole search history, every comment I ever ledgered. A whole lot of information is hiding, including IP addresses of every single device that you use to log in, including the information of the name of that device. So one of the things we want to be able to do is educate people. We want to be able to talk about something, we want to show how to visualize that information in 3D. And so we want to be able to let people know, first and foremost, there's a whole lot of information you're giving away that a third party can have access to. Second, this is only a portion of that information that you would actually be able to see. There's a lot more that's hiding on Facebook servers that we were not able to get. And the third is that they actually create a custom profile about you. This is based on things that you click that maybe you don't feel like you're connected to, and soon I'll show you some of mine.
As a first step, we created personas and user stories. We defined persona for 4 personas. This persona is fictional characters generated by auto-generated site from here. So I explained about 2 of them. First, he is Coda. Coda is 12. His parents created his Facebook account for him when he was 4. They made a post on his behalf before he was able to type. Recently, he wants to delete his account, but before deleting, he wants to see all of his data. She is Sarah about to graduate college. She has been a very heavy Facebook user from 2007. She is not sure how she's come across a potential employer, so beforehand, she wants to see her data. Yeah, we created features. Users can read defined JSON files only by selecting a root of folders. We created new class to pass out difficult object nested in JSON data. And we created some view of, for example, shows a list around us, or summary of a number of lists and list with pictures.
We're going to share with you the demonstration. One of the things that we ran into as a problem was Chromecasting to you. So if I don't get this up in the next 10 seconds, then we are going to continue forward until it is available to share. Oh, I wish that that's what I was going to cast into. Let's continue on. Okay.
So before showing you demo, let's check out what is this Facebook data. So there are a few things we realized that Facebook has been doing. For example, if you connect your contact list to Facebook, it will store the names and phone numbers. All of them are stored in Facebook. Also, maybe you may have experienced that Facebook has been asking you that maybe you're in this picture and you are actually in that picture. That's because Facebook knows how your face looks like. It has facial recognition points. Also, as Ian mentioned earlier, every single message, comments, search, everything is stored there. And porks have ratings. We don't know yet what these ratings mean, but it has rating. Also, if you're using Android uses calling timestamps. They are also stored in Facebook. There are some very strange features that we realize in Facebook.
Okay, now let's talk about what technologies we use. The application is written on Unity, which is a game engine that allows you to create 2D and 3D games. Our main programming language is C#. We are using Travis CI for continuous deployment, and we found a good use of Docker containers that I mentioned before, and we are using also Amazon S3 buckets for our releases. So how does it work? You have to download your Facebook data yourself. We cannot do that because it's so private. The information is real private. You have to also load it to the Mindsweeper application. Everything happens within your local machine. Nothing goes to the internet. The only thing that goes to the internet is an API call to Google to get images for businesses that have your information, but we are not uploading your information to any other service. So I'm going to talk to you about the engineering challenge that we faced, and the first one was how to build a continuous delivery pipeline. And we have a couple of providers, Circle CI and Travis CI, and we went with Travis CI because we thought that it was going to be so easy. It was just going to be a single configuration file, a couple of lines long, just tell the language that the application is written to, and it will build. But it turned out we were wrong, very, very wrong. But Docker came to our rescue, and so we were able to get the ability to use Docker containers within Travis CI to build our application. So we were able to come out with this configuration file that is much more complex, but we were able also to get a build path. So how does the delivery pipeline look like? When a developer makes a change in GitHub, that triggers a build on Travis CI, and that will use Docker containers to build our application. And when that is built, it will deploy our application to an Amazon S3 bucket. We also created a website that you can use to download our application that talks directly to that S3 bucket. That website is deployed on Roku.
So there are many challenges. Here's a sneak peek of our application, and we have created this application not only for VR, but also for desktop. So we created this application for Mac OS, Windows, Linux. We've been trying so hard. But the problem is there are some different configurations for VR and for desktop. So every time we click some object, it doesn't work. That's because of this configuration. And we spend so much time to figure out what was wrong. Also, there are problems. Like when you are using web application, you never think of the distance between the pointer and the object. But this is since 3D. You have to think about the distance between the pointer and the object in space. You cannot really see in the screen. That's why we struggle so much. Also, there is a problem about game engine. So first of all, for the first time when display the old text, we realized they need to be converted. So we figure out they are not Unicode but Latin 1, which is very rare code, and we converted them into UTF-16. And then we realized that there are not all the text displaying, so we have to fix that. And then we realized now Japanese text is not shown. So we have to, we ended up creating the font asset for Japanese. Also, there is a problem about the .ignore. So we use this file to avoid us from uploading all the files because some of the files are very heavy, but realize that actually file is about the position of the object in Unity. So when we didn't upload these files, that affects everyone's basic environment in Unity. So that was also a problem. So there is another challenge. It was about algorithm. So when we had to develop algorithm, we have to really understand what the data structure will be like, and also how C# works with that. Because we've been studying JavaScript, C# is a new language, and we have to really understand how it works. And also, English has a space between the words, but Japanese doesn't. So when you have to make a new line, you have to think about like different solution for each language, basically, mainly for English and Japanese. Also, there are many unexpected edge cases. So sometimes your JSON file doesn't have this data. Since these JSON files differ from person to person, we had to figure out how different they are, and we had to think about each edge case.
Another challenge that we faced was being able to allow a application permission to be able to have access to the local hard drive. So it's one thing if we're using this on the desktop. It's one thing to be able to open a file and then be able to log it into our application. It's another thing to have it saved directly on our headset. So we had to come up with a very special way of being able to determine what that file pathway was. And then in addition to that, which it actually wasn't even stored in the folder marked SD card, it was stored somewhere else, we also had to create a function that allowed us to request that permission. So when we end up seeing this, eventually, as I'll show you soon, when you're able to see that your application is asking you for permission to be able to actually have access to the local hard drive, it was like a hallelujah moment for us. But as soon as we actually ended up finally being able to implement it, it ended up breaking just about every single part of our application, and then we had to refigure it out from there.
As I mentioned before, we built a website, and I'm going to show you guys real quick. In this website, you can find additional resources and how to download your Facebook data. There's instructions. Also, there's instructions about how to download the app. Where are these files? Because there are so many files in the Facebook data that you download. So it's not always clear what these files are for. And we have a brief descriptions of what these files are for, and the list is huge. Also, a couple of things of how can you improve your security and how this does the Facebook has your information and how is it sharing it.
We have connection now. If you all are willing to take a dive into our application, thank you all for your patience. This is what it looks like. So starting off, we have our, wait, I might need a microphone, thank you, Toshy.
Wait, is it actually working?
Yeah, can you see it?
Not moving.
Oh, well that's because let me hit start the application. Do we have live?
No.
This is the fun thing about this. We're learning a lot about how Chromecast streams. It says that I have complete permission now. So this is what the crooked head looks like. Oh, what was that? Oh, no. I feel like we're all on the same page now, where it's like you feel just as strange as I do. One more time. All right, I'm casting, and no destinations are found. Let's walk through some of our future features. I have an idea. Here.
Yeah.
Can we switch back for a second?
Yeah.
Future features. Just now, we could support it, some of JSON files. So in the future, we will visualize all of them, and we will use text analyze and personalized metrics. If we create it using technologies, users can be sure, so seeing some viewpoints, for example, classified public or private, and some keyword searching for, users searching for, and we want to realize more friendly and interaction. And we want to support it running on the browser. For example, WebGL, because just now we supported specific platform. So without depending the platform, if you are interested in our application, please check this QR code and please check our profile. Thank you for listening to our presentation.
With everyone's permission, I want to walk you through how to download our app in live time. So if you were to visit our website and open the file, it will end up asking you whether or not you have permission to use it. Something about the internet here. It's moving very slowly.
Are you in the form?
Mm-hmm. Yes. Sorry, wasn't that part. So it says it's not commonly downloaded. Choose to keep this application, and then open. So it's not connected to VR, but in this environment you have the ability to look around, and this is the way you would expect to see it in VR. If you end up logging in, it ends up asking you where you've stored your data. So, for example, I'm going to share with you all of my data right now. I don't advise ever doing this in public, ever. So first thing we might want to check off and look at is, let's see what my ad interests are. So it says I have 85 public interests. Let's see, that includes Will Ferrell and Women. Women is a band, I just want to clarify. We have Star Wars, we have Skin. I like Skin, evidently. Some very odd things in here. Tool, I've never listened to Tool. Let's see, what about apps and websites that I've logged into? Yelp, Discuss, Tumblr. These are all the different times that I've logged into every single one of these applications. I also have the ability to look at, God forbid, my search history. What's at the top here? My ex-girlfriend. 29 times. So if you're ever looking to figure out exactly how many times you've looked at people, this is unfortunate because my fiance is in the audience right now. I love you, babe. Other things that you can be able to do, if you haven't had enough, you can also explore what your comments are, which can actually go way off into the distance. You have the ability also to get closer to them. You can move up and down in VR space as well as in this environment. So if you can't read it, you can get even closer. And then as well as we also made it possible so that all the advertisers that have your personal information, which for me is 886 different businesses. You'll see that some of these pictures that are loading right now have question marks. That's because when we do that Google API call, it can't actually read the image file type within this application. So as it was said before, no public information is going out. We're just trying to figure out exactly Activia. That's for people who have bowel syndrome, if you want yogurt. I learned a lot about myself through this, and this is only like a fraction of all of the information that exists. And so I know that we front-loaded all of the expectations that we have for this, but by the end of it, we want to be able to give people a fair understanding of how everything is being contained all in one place, and to be able to live in that and see it and be educated by the kinds of weird things that can be manipulated, so we can tell what kind of person you are maybe, how many private good things you've said versus bad things, versus all of the messages and the conversations that occur. Thank you all very much for coming out today. And if anyone wants to see the VR helmet, it works now, so baptism.
Thank you very much, Team Mortar and Pestle, for this fascinating presentation. I'm really glad that we're all able to see the application at the end. So this brings our presentations to a close. I want to make a special mention to the staff at Code Chrysalis and thank them. So shout out to Felix, shout out to Krista, shout out to Dylan, to Dustin, to the founders, Jan and Connie, to Heather. Thank you very much for having taken us through these amazing 12 weeks. Yes, thank you to everyone here for coming and sharing this moment with us.
Yeah.
So who here is thinking of attending the immersive? Excellent.
Oh, there it is.
Hello. So my name is Yan. For those of you who don't know me, I'm one of the co-founders, along with, thank you. Thank you. I think we're good. Felix has saved us once again. Yeah, so really quick, this is our 7th class, which means that the next one, class number 8, at the end of that, we will have been here 2 years. So Connie and I came here a little under 2 years ago to start the school here. And at the time, there were a lot of people who didn't really understand what we were doing. They thought we were really crazy. Starting a coding school in Japan and then teaching it all in English. It was tough, but you know, a lot of people look at us and focus on certain things. They look at our curriculum and criticize the JavaScript. They think it's crazy to have something like this in 3 months and to promise so much. And we really wanted to show people that language doesn't matter. We're here to create software engineers. We're here to graduate software engineers, not JavaScript developers, not Ruby developers. Flexibility and autonomy, the ability to create and pick up technologies really fast, to be able to understand it, understand the concepts. So much of nearly everything that the students have presented today, most of these are things that we don't teach at all in our curriculum. We don't teach C#. We definitely don't have anything related to IoT. We don't have any VR. no blockchain, none of that. And so the fact that they have been able to use us as a base to explore the world of technology, I think that's really, really special. And I really want you all to be really proud and impressed by how far these students have come in only 3 months. With the exception of the final 2 projects that they have shown, the rest of the projects that they presented, they only had a couple of days to do those. And that's something that they didn't mention. They're a little bit too humble to mention that, but most of these projects, the max number of days they really had was 4. So imagine learning Kotlin in 4 days and also producing an app. I think that's incredibly impressive. If you want to learn more about them, you can find all of their information on our website, codechrysalis.io/cc7. And also, before I let you all go, I want to welcome you to attend our next demo day. CC8, we have 12 awesome students. We weren't able to fit all of them on here. So I picked the ones with the best pictures. But can all the CC8 students in the room raise their hands? I see y'all, yay! June 27th, please mark that on your calendars. And we're really excited to welcome them into the family. Before we wrap up, I want to also invite Kani up to say a few words in Japanese.
こんにちは、こんばんは。なんかここに来るといつもちょっと感動しちゃって。ちょっと言葉が出ない時があるんですけども、本当に3ヶ月間でここまでやるっていう、毎日逆に生徒さんにうちらがスタッフがもうエネルギーもらってる気がします。で皆さんも真剣になんかこう、考えてやろうと思えば本当にここまでできるんだっていう、毎回3ヶ月ごとに、見れて、すごい非常に、ラッキーな、立場にいるんだなって思います。で、CC8 の今度のクラスの生徒さんもここにいますし、過去の生徒さんも何人か見てるんだけど、本当に毎回、感動します。で、ヤンさんが言ってたのが、コードクリスタルの話はなかなかとしたくないんで、ただ一つだけ、2つぐらい何が違うかっていうと、見た通り、生徒様の自信とあと、自立性が JavaScript でソフトウェアエンジニアリングを教えてるのにかかわらず、皆さんは最終プロジェクトを C#、3週間で C# を勉強して Unity でバーチャルリアリティのアプリ作ろうっていう、もうとんでもない発想に走っちゃって、やりこなすっていう、そういうエンジニアですね。本当にこの先日本を支えていくエンジニアリングリーダーを育ちたいっていうのが目標です。で、IoT デバイスに関しても、ウェブアプリを作ってそこで満足足りなくて、IoT デバイスもカップリングして作っちゃいましたっていう、本当にとりあえず大きな拍手でとりあえずおめでとうって言いたいんで、おめでとうございます。どうも。
The next available cohort that we have is July 8th. It's more than 25% full already, so if you're interested, please apply soon and start the interview process. We also have a class starting October 7th and next year, January 6th. You can also find us on all of the internet things. The information is also posted around the room. If you're going to be tweeting out about today, and please help us. Please do hashtag CC Demo Day and also tag us in it. And lastly, thank you for coming out. Thank you for the support. back and beer. Please don't leave. Please hang around. Please meet each other. Please say hi. They will be demo.